Hello, welcome back to IT Landy. Previous session on exercise 5, task 3, we did enable like a load balancer with public IP, and then we done dynamic porting. For today, task 4, we will update the external surface to support dynamic discovery with a load balancer. Similar to the previous sessions, we are using the dashboard, the GUI part, navigate to localhost on port 8001, dashboard, select deployment, workload, and then click edit. From the edit deployment dialog box, scroll down to the web container as shown below. Go remove the host port entry for the web application port mapping. Yeah, it's line number 40 to 46. Click update. From the web deployment view, select scale and enter 4. Now look at the status refreshing after a few minutes, and then look at the web deployment. This time it is down to number of nodes are available to match the following requirement. Like the API deployment, the web deployment used a fixed host port, and your availability will be limited to the ability of the scaling to meet the requirements, on the CPU constraint and the RAM and whatever you allocated. Yeah. So you can see it's 2 out of 4 like before. Now, if I would like to improve my constraint, what I do, task 5, adjust CPU constraint to improve scale up and scale down. What I need to do, similar to the previous one, you should be familiar by now. Dashboard on 8001, navigate to deployment, workload, view deployment list, select web deployment, click edit. Go API, I go web deployment. Now from the edit, find the CPU resource and then change the value to meet your requirement, which is 128 this time. Yeah, minimize it. Select update and then wait for the replicates to replicate, refresh, and then hopefully after that you will see it all green. Yeah, because I have enough resources. Return to the browser tab, load, refresh, and you will see reflecting different pods, observing host name, refresh. And the last time, what we do here, you will add the web application code and update the Docker image used by deployment. Then you will perform a rolling update. Yeah, so we need to update the image this time. So ignore the previous one, no more dashboard. Yeah, go back to connect to the agent VM using SSH. Repeat task 6, which when we did the pre-req. Yeah, command line, write vi server.js. Click I, insert the mode, go back to the endpoint definition. You can see it's highlighted data.web task ID. Now update. Change the sets data web task ID with the following: equal process any host name or environment host name. Save it, colon WQ and enter. Your current Docker image for the web application should be version 1. Verify that one through the command line Docker image. List the images that should be building on 1. Now, if I want to operate a new one, what I do? Build a new version with Docker image, and this time I'm going to tag it with version 2. Docker build /t, name of the server, which is like the ACR, and I'm targeting the content-web build. This time I tag it with version 2. Okay, so the latest will be version 2. Push the image, Docker push, server to web content, latest and version 2. Now exit from the WSL request rolling update using kubectl command. What I do, I set the image to version 2. While this update run, return to kubectl dashboard browser from the navigation bar. Have a look, see how that will look like if it's fully deployed with the right version, something like this. Yep, this task, I've got the new version and they're getting updated one by one. And then you open the second browser, view the application page, have a look at the task, and you will see and the host name is replicating, and that should be the last part of this exercise. So it's really crucial. Let's just repeat this one. I just need to make sure you know how to update the image. We go back, external surface, then we went to the image CPU, and then the last part is this one here. We said, okay, we do rolling update. We went to the VM, we connected to the configuration, we went to the directory, we went to the VI server, we navigated to the process ID, we replaced process.pid. Yeah, pid, if you look at my screen, it will be the pod ID. And this time what I did, I replaced it with host name equal process.environment.hostname rather than the pid itself, pid ID. And then what we did, we created a build image this time with version 2. Now we push the image to the ACR, then we viewed it from there. Yeah. Then last thing, I went to the kubectl. I said set image deployment for web to the server. Basically means grab it from there, yeah. And then I deployed, and this time it's using the right image number, and it did reflect based on the tag we deployed. You can view that one via the task ID on the second browser. Hopefully that's helped you, to understand what we have done. I'm just gonna recap all of these quickly, and hopefully it helped you to understand what we have done so far. So next, you can improve, and there are plenty of Microsoft, exercises and documentation you can read and improve and work on it. But for us, this time, what we have achieved, what we have done, we did a step-by-step hands-on. We created a POC AKS. We deployed Linux VMs and Windows for management with WSL Linux. And then we created Docker image. We pushed to ACR. We pulled from ACR. And then we did the HA, and we did scale up and scale down. We tested availability. I would recommend you go through this and go through Microsoft website to make yourself familiar with this, and hopefully it was useful. Thank you for watching, and goodbye for now.